Good afternoon. Okay, good afternoon, everyone. I'm just going to also record the class that I did on the 5th of September for the other students who may be interested. So basically, I want to cover Project 2 feedback very briefly. I'm going to show you how to do it. I'm going to do a demo of the web app, and we are going to be looking at dependency injection and repo pattern. And it's just background for you to understand a little bit better what this project is all about, and the concepts. I just want to explain some concepts to you. Right, for project 2, yeah, just before that, I just want to mention, that you just are aware of it, that project 3 is then due 21 September, project 4, 19 October. And what you basically see is that, this is basically where we have our holiday. We're having our holiday in that time. So those 2 weeks, we will not have class. So you can see that you have to hand in on the 21st of September, but there will be other things going on. And then we will have what you can see here is that that is when we have our semester recess. And so the next class that we will have after, so we'll have this class, and then we'll have again that clause so that you're sure about what it is that's going to happen in the next few weeks. And so we have then on the 21st of September, project 3. Then here we have project 4 on the 19th of October. You can see it's over there. And that will then be UiPath. So basically, we are going to be doing this lecture on the 14th of September on UiPath, and you are going to be spending this time. So you see, you've got quite a few weeks that you can spend on project 4. And then on the 26th, we will be giving here on, so when we return, we'll do the Power BI project. And on the 26th, project 5, the Power BI project can be handed in. It's optional. So those of you who've been doing well, don't have to worry about project 5. It's only for those students who really have to catch up. Right, and so I think after doing project 2, you now have a better understanding of what is expected, and mainly what I could say is diligence, So we've given you 2 lectures already on the project 3, and so hopefully many of you have already now started working, looking at what the assignment is and what was done in class, and really getting going on it, because that's the best way for you to be successful is, to really be devoted and to work very hard, to do your planning every week and to keep to it, to spend your, 11 hours. That means you have to spend more than a day per week. 8 hours is normally considered a working day. So 1.5 days per week you should be spending on your project. Do your training, keep track of what you can submit for your POE, and so forth. And so, this is how we want to grow you. We want to make sure that when you leave the course, that you understand how to work against time, and how to get things done properly. And yeah, the main problem that we see is project planning is one of the main issues. People can do the work, but they haven't planned well, so that is the problem. And yeah, this is a slide that I showed you, in the beginning, and this is where we are today. For many of you, we are sitting here that it's not that pleasant, but if you stick with it and you do your work and you do your best, things are going to end up very well for you. Just a reminder that we keep on the wiki updates of what the requirements are, where we are busy with. So have a look there and you'll see we are now, well, this is already last week, but this is where we sit. We are in progress with a certain sprint and then the others are done. So just check always the wiki. That's where we communicate with you. And yeah, just remember that all the resources are available in the resources tab. We've updated all the slides in the slides. You will find the projects there. Any notes and guidance and so forth is available. So make sure that you know what's in these folders. Okay, so for project 2, basically what went well, if we look at what we got back from everybody, generally many people could manage the hosting of the database, the API project, the creation of the controllers and so forth. Yeah, so if you managed to actually do that well, then there was no problem with that. But, the last little bit was the security, and here people struggled. And there were lots of people that, like you could see over here, time management is a big problem that people couldn't do. Lots of errors that you pick up, lots of problems. And very often this is when you leave things too late and something small goes wrong and you haven't got enough time to then sort out that problem. It doesn't help if you like 2 or 3 days before the project's due, you now install the tools and now you sit with this big problem and now nothing is working. So if that was you, I hope that you've learned from this project, and for project 3, you won't leave it until the end. And when we asked you in this slides, then what could be improved, and this is for yourself, you could see, generally most people understand that they spend not enough time on their time management, that you have to plan properly and make sure that you understand what the project is all about and get going as soon as possible. When you're busy implementing project 3 now, make sure you understand what is required of you conceptually. Go and take a piece of paper, think about it first before you just start coding. Keep versions of your code so that if something goes wrong, if you've got a version going, it works, and you want to go to the next level with the code, then you've got a backup of that. And if anything would go wrong, you can then revert back to your previous version and you can continue again. So make sure that you do those things properly so that you just make life easier for yourself. I will do the demo at the end. Okay, so what we are going to talk to you today is dependency injection. So dependency injection is something that you have seen in project 2. But for most of you, you may not perhaps understand exactly what it means and how does it happen. So we talked about, you do dependency injection. You may not even exactly know where it is in the code, but this is a principle I want to explain. And this principle will help you to understand the repository pattern for project 3 a little bit better. So that's all that I'm doing in this discussion. Okay, so what we want is we want code, and this is why we do patterns. Why are we doing the pattern with you? We want to make sure that you can write loosely coupled code. That if you should change code somewhere in an application, you don't have to change it all over the place. Because this makes code more resilient and it's more productive to do it like this. Right, so this is where we are discussing dependency injection and the repository pattern. Okay, so related concepts that we are considering are these two related concepts: inversion of control. Okay, we are going to look at what that means. It's a principle, and dependency inversion principle. And so from the discussion that you've had before, this is one of the solid principles, the last principle that we saw that is important, and we're going to look at what it means in terms of this discussion. Okay, so the inversion of control principle, basically, we can apply to code. When we say, right, in my code, what I can see here is I have a number of classes that are calling each other. And, for example, let's just have a look in this case here. The business logic calls the data access. And the data access will return some data. So basically, what we want to make sure of is that if there is a change happening here, I'm not going to have to do any changes to my business logic that are major. Now, what you must remember is that a data access class is something that will be reused in an application a lot. Just about everywhere in your application, you are going to be calling the database and getting access to data in some way. So if you, for example, should, let's say, decide to change something here in terms of where the data is stored, then it means that every single class that is calling your data access class is going to have to be changed. And that is something that we want to avoid. And we want to make sure that, we have loose coupling, which means that the two classes will be more independent of each other. So let's see how it practically can be applied. So here I have, you can see here I've got a class called customer business logic. And here I've got another class called data access. And so essentially what's happening is that it's exactly the example I've shown you just now, that what we see here is in the class customer business logic, we actually instantiate a new data access. You can see there. And then what we do here is in this, let me just quickly see here. So basically what we will then call the data access, and then we're going to say, I want to use the customer name. So that's something that we will be using, and you can see that data access has got something there, customer name, that can be returned. So it's a dummy value that is being returned. So basically what we see here is that these are tightly coupled classes, right? If anything should change in data access, you'll have to change something in customer business logic. Right, so basically what we can see here is that a call is made from top to bottom. A call is made from the customer business logic down here. And one of the things that we need to consider is that there is a keyword that we always look for, and that is the new keyword, okay? The new keywords, when I'm looking at that, I can see that I'm instantiating a new data access class whenever I'm going to be running my customer business logic. And this is causing a problem. This is where the tightly coupled situation occurs. So if anything should have to change down here in this part of the code, if you change anything here, you'll have to change the code there as well. And you'll have to do it all over the place. So this is where the problem lies. Okay, so basically what we say then is we want to have a solution. And this is where the inversion of control principle is going to be important. So this is an important thing that we want to change is don't call me, we will call you, okay? And so we invert control to another entity to create the data. So what we see here in this case is the data is created inside the customer business logic by using the new keyword. And we say, no, we don't want to create it there. In other words, when I'm a class, I'm running, and for every new class that I want to make use of, that I instantiate, I create it at that point in time as I'm running. So what I say is now, this means that I have to do all this work. I don't want to do this anymore. I actually want to revert control somewhere else so that this class is created somewhere else. And so basically, the principle would be that the customer business logic class should not have a concrete implementation of the data access class. It should rather just depend on an abstraction of that class. For example, we want to create something like this. I get data access some interface so that I will actually depend on an interface. So how would this work? And this is, if you think about the project that you are going to be doing, we demonstrated to you that you are going to be making use of interfaces as intermediate layers between the actual code and the actual data. And so this picture illustrates it quite nicely. So I have my business logic, and as I look at it in the normal way, you'll see that without dependency inversion, there is a call from a higher level to a lower level. And you can see that a call is made to the database, the data access class to some database, and they are tightly coupled to each other. But now when I invert control, so what I want you to notice is that the arrow is now changing direction. Control is now flowing not from the business logic down to the data access class. It's going to be changed. So on the same level, you can see now on the same level here, this is quite important. I'm going to be creating an interface class called iRepository, okay? And this interface class, you can see here down here, the data access layer, the control is now from there to there and from there to there. Okay, so I have an interface, and the data access is an instantiation of that interface, which makes this whole thing much more loosely coupled. Okay, so then therefore we know that abstraction should not depend on details. Details should depend on abstractions, and that's exactly this arrow that you see here, is that details depend on abstractions. And so it's important to understand here that the layering is quite important, that the hierarchical design, that the interface class and the business logic class are on the same layer, and then a layer below that is our data access class, which now depends on the interface class. And so now control has been inverted, as you can see here. Okay, so we can perfectly do this inversion of control that I've just shown you here. but we can still violate the dependency inversion principle. And that has to do with, as I've mentioned to you, by the high level and the low level modules and the direction of the dependencies between them. And so in ASP.NET, we make use of something called dependency injection. And this is a way to achieve inversion of control and dependency inversion. And essentially what we do in dependency injection is you ask for an instance of your class from the dependency injection framework, and it will instantiate one of the classes you're asking for. And you may have done this now in project 2 without realizing it. You did actually implement this, but you did not realize what you were doing. So let's see how that would work. And we find, that dependency injection is a concept that is implemented in the ASP.NET MVC core, but also in Spring and all the other frameworks that we make use of. It's a very general concept. They all have a dependency injection. Okay, and then just look at a simple example. A car class might create its own engine. So if you have, for example, a car class, the car class is going to create its own engine. And very important always is the new keyword. So I have a car class, and I'm going to create an engine, and I'm going to instantiate it using the new keyword. And so these two things are then very tightly coupled, and it's difficult to make changes or test the car class independently of the engine class. So I cannot execute the code here in the car class without also executing the code of the engine. They are tightly coupled to each other. Whereas if I say I have a car class, okay, but somewhere else I want the engine to be created, and I'm just going to be using it using some interface, then we don't care where it comes from. I can actually test the code here without bothering about where the engine sits, and just makes this whole thing makes it much more loosely coupled and maintainable. It's more maintainable to do code like this. So that's the difference between the two. When we're doing dependency injection, we can do it in different places. And the one that we were using is constructor injection, where we actually are injecting dependencies through the constructor, but you can also do it through a method or through a property when you make use of that. When we are doing dependency injection, we can actually have different types. So these different types are, for example, at singleton, and this is when you want to create an instance of a service and you want to do it across an entire application. So that's quite heavy on a system. Then we have something called add scoped, and this is where we have per client request. So this is, for example, for a database repository and database type of things, you can do it here. And then we have add transient, and this is for very lightweight, and this is the preferable place to do it. Whenever you need something and it's a very lightweight status operation just for some instance whenever requested, and then it will immediately be removed after that. Okay, so how do you know that you have problems and you actually are in a situation where you would rather make use of dependency injection? Is when you are referencing a low-level module from a high-level module, then you know that I'm doing something wrong, okay? When you find it hard to code or replace a low-level part like a database, you're making too many changes. You see that your code is not very maintainable. You're finding it difficult to do unit testing on a high-level component because you have got so many low-level things inside your code. And then the keyword new. And we know that I've shown you how that works. So when any of these situations occur, you know, okay, I perhaps should consider something else. Okay, so how do these things all work together? Because dependency injection essentially is some design pattern. So what we see is the two principles I've discussed with you are basically inversion of control and dependency inversion, and these are principles. So this is just an approach. This is just the way of looking at things and the way of doing things. So they are just, we consider them and they are best practice. But then we have something called dependency injection as a pattern. So this is then a pattern. This is how we implement it. But then for our purposes in ASP.NET, what we have is we have a framework, and the framework is called the inversion of control container. So there is actually a container sitting inside your framework that you can manipulate via classes. And this is actually where the implementation this is what that is what you're actually going to be working with when you are writing your code. Here's just an example to show you how it works. So here I have a dependency injection engine and I ask it, I need objects A and B, please give me those. So that is a class. So I'm a class, I'm not going to use the new word, I'm not going to instantiate anything, I'm just going to say, give it to me. And so what does the dependency injection engine say? Yes, I'm going to now start creating, you can see it's now creating those instances inside the dependency injection, and it will then say there they are, and you can continue. So in other words, this is the engine that we are talking about, and the engine is doing the instantiation. You ask for something, you get it back, and you can continue. And that is why when we ran our code, sometimes you would get the error that the dependency injection has not been set up or there's an issue with it. And this is the reason then is that the whole process of actually accessing the dependency injection engine has not been done properly. You may not have registered your service or whatever it is, you did something wrong somewhere along the line. Because obviously your dependency injection engine needs to know what are the services that it actually has to understand which services are the services that it has to instantiate and pass back. Okay, so in terms of ASP.NET Core, you can see that we have at the top, we have the MVC, and then we've got things like logging, configuration, hosting, and dependency injection, all part of this framework. Okay, so let's have a look at the controller. So what do we see here is we see some home controller, and we see that there is an index action method, and it has a dependency on what we see here is now exactly what we don't want to see, is we see that inside our controller, we are going to instantiate product service. And so it's going to create some instance of it. And then when it's created an instance, I can now start using methods like getAll. Okay, so this is then where we are going to struggle with code. Code is going to not be maintainable. It's not loosely coupled. And we say we want to get rid of this. Okay, so another problem that could happen is that, let's say we want to change the product service into some other class. We want to rather use something called better product service, and we want to replace it. And so this could, it could mean that this product service is being instantiated all over my code, all in many different places. And so what do I have to now do? I have to actually go and update all my code wherever it is referenced with a new word there, better product service. Then I can actually recompile all my code, and I can then again use a method getAll for my better product service. And so then again, you can see here, this is a problem. It's going to cause a lot of maintenance. All right, so what do I basically do for dependency injection? And now this is something you did it in your code, but you did not realize that you were actually busy doing it. So here we see our home controller. And what we said is that we can actually ask for our service using 3 different places. And one of them was in the actual controller, okay, when we are doing the constructor, okay. And so how should we look at this now? So here we see our home controller, and I see here interface, iProduct service, and then product service. Essentially what I'm doing in these brackets that are sitting here, I'm telling it, okay, I'm telling MVC. MVC says, okay, I'm going to run the home controller, and what does it see? What does the home controller need? It says, oh, it needs something. There is something that it needs. And what you can see, it is then using the product service here, but there's nothing being instantiated. We never did that. So the instantiation is happening somewhere else. And essentially what's happening is that this statement here that is running from the constructor here is actually now telling the container, please go and instantiate for me a product service, and then return it, and then I can continue, and I can then use the method over there. And so that's essentially what dependency injection is all about. It's very straightforward. Okay. So basically, the ISP.NET Core Dependency Injection Framework takes the responsibility then for creating the product service, and it's done via we can call it the dependency injection container or the IOC container, which is an object, and then it will just pass through the object that you request from it. Okay, and so then basically that is then, yeah, this is essentially just the same code, and that is then how it is done. So what's important then when we use this, and this is a very important point, is before you can do dependency injection, you have to register your service in the program.cs file. And this is an example. So where we say builder.services.add scoped, we are going to now register the product service in our dependency. And this is how it knows about it. Because somewhere you will have code for this. There is code, there's a class that you did create somewhere in your code. But now this is where you just register it. Now it knows about it, and now it can actually pass it to you when you ask for it through the container. So this is basically what the container looks like. So basically I have my home controller. My home controller is invoked. It says then, okay, give me the iProduct service. The dependency resolver is going to run in the background. And you'll see now in the background in the container, there are two services that have been registered, the product service and the better product service. So it will then see from the, when you did you did ask for product service. It will then go and find, okay, well, I want to take that one there, and it will return it, and you will get the product service. And if you should then decide, well, I'm going to change it into something different, you register the better product service, and it will return the better product service. So your code, there is only one small change that happens in your code, and then that is basically when you set up your controller, like I'm showing you here, you replace it with a better product service or the test product service or any other product service. You are just going to then register it in your, when you register it, and then your controller will have to reference the better product service. And so all of this is just managed from one central place, which makes it so much better. Okay, and just another example, now this is where we mainly used it in our code also. The DB context class, for example, here I have, after scaffolding, I have a DB context class for the products database, and you can see, I'm using over here, and then what I have to do is I have to go and register it. So then I want to use it there. And so I'm going to register it, and you can see I'm going to go into my program CS, and where I register it, I'm going to say add DB context, products DB context. So I register it in there in the dependency container. And so essentially now it is ready to be used. And so you can see when I instantiate my controller, I'm going to reference the products DB context with context, and then I'm going to be able to make use of context. And you can see over here, I'm going to use these methods that are available here. So that's basically what we also were doing in our project 2. Without really understanding it, you're using dependency injection. So your products DB context, the session with the database was it was a bit of code that was written, and it was there available, and you then registered it, and you can actually now access it through the controller. So in the controller, you can now be accessing the database using the context. Again, this, if we look at our EcoPower solution, this is sort of what your controller would have looked like. So in your controller, you see here, you are using the customer controller, and there is EcoPower Solutions context, and you are using it there. But where was it instantiated? It's instantiated in the dependency container, but this is where you register it. So we had this statement here that we register it here inside our program. So yeah, this basically then shows you how dependency injection works. And the whole idea that I want to demonstrate here is how we have passed control somewhere else. And it's just sort of explaining to you the whole principle of inversion of control. So I'm not calling code anymore or instantiating code anymore out of my business logic. I am now writing some data access code. I'm registering my classes that I'm going to be doing data access with in my program CS file in the dependency container. And then from my controller, I just make a call. And this is essentially the principle that we want you to apply in project 3, but using the repository pattern, which is then something different. And so your repository pattern is essentially, like we already said, it's like you can now be using many different data stores, many different types of structures, and you don't want to be affected by any changes. So if you decide to go from relational to MongoDB, your actual data access classes should be there, and the code should not change dramatically if you're going to change the way in which you access your classes. So basically, your repository pattern is an abstraction layer between the data access layer and the business logic layer of the application as to ensure loosely coupled code. And so what we are now going to be doing is we are going to be implementing a number of layers between the business logic and the data access. It's called the repository, so that it has that responsibility of persisting the application's business model. So when we have no repository, this is what we would have had, and this is what we had in project, in previous work. So you have your web server, you have your controller, your DB context, and then you have your data. But what we now want is we want a new layer being built in between. And you can see there we have a repository layer, still using the DB context, and then we have our data at the lower layer. So this is what you want now. You want to build in a new layer inside. And so, like we've already showed you, what we normally would have had is we have for the model view controller, we have folders, the model and the view and the controller folders. And then what we had is we had files. We had the program file and we had the DB context file. And so what we now want to say is, okay, well, I want to now make it more loosely coupled, implement the repository pattern, and we have a whole new layered approach that we would like to create. So you can see here we have our DB context, and our DB context, you can see, can interact with various types of, it all depends on what the DB context is for a SQL database, and you can have different context files than for others. So that is where you actually create access to the actual data. And what we now can see is what we now have at the top is on the folder level. So here we just see 3 folders, but on the folder level, we see we now have a repository and a data folder that's being added. At the bottom down here, we see we have a class that has been created for the purpose of accessing our data. And above that, we have a layer for our repository interface. So these are then on file level. So yeah, you can then see this is mainly what the structure of that project should look like. And then just the last point that's important is when you create controllers, it's very important to make controllers as straightforward as possible, okay? And so what we see here is here's a controller that's got a few lines of code. And this can grow, so a controller could be like here we say get product, but then you can start doing a lot of other stuff. And controllers can become quite heavy to maintain. But what controllers really should be? Controllers really should be entry points into your application. They should not be places where code is kept. So essentially, when we look at our controller, what we mainly should see here is that there is just, you can see one line of code that is actually just going to call some service that is going to say get product and apply discount. So that is something that you call, and this is essentially all that is in your code where your controller lies. And your controller is an entry point. This will be called, it will execute a number of lines of code somewhere else and return a result, and you'll have your answer. So always remember that, that controllers are entry points into applications and not places where a lot of code is stored, even though in this project we may be doing it. Right, and then finally, what I'd just like to show you is just how we create our web application. So I'm just going to create a new project. And what we now are going to be doing is we are going to be creating an ASP.NET Core web app. model view controller. So not the core web API anymore. We're adding in here, we are adding in the view. So I'm going to say I'm going to create that. You can call it a name. Okay, so let's call it something like that. I hope I've got that a free. Okay, so then we get to the next screen. And so what are we going to choose? We are going to add a bit of security. We are going to be using individual accounts. If you are going to be using the identity platform, a lot of additional things will be created for you that Microsoft namespaces support. Windows will be integrated with your credentials on your computer. But for our purposes, in this little demo, we are going to use individual accounts. Okay, I've already got a name like that, so I thought that individual accounts. Okay, so when we look at our basic application solution that is being created for us, let's just notice some new things. So in terms of what is being added in packages, what we see here is we have our identity entity framework core that is being created. We have identity UI, and we've got our database packages that has been added. So that has already been done for you, and there's nothing more to add that we need on that level. What we see here is our www root. That is the root folder normally of where your web application is hosted. And here we normally with things, cascading style sheets, JavaScript files, and things like that. So those are all the types of files you need to maintain a web application. So here in areas, you can see there is some identity stuff sitting here that are created. Then we have our normal controllers. Here we have our home controller. And that is just the basic home controller that we are going to be looking at to just interact with what is available, which is not much at this stage. We have our data, we have our models, and we have now, in this case, we have views. So what we see here in the views, we now have an index.html page, we have privacy. So you can see these are the things that are going to be displayed on your web pages. When you are going to be running you've got some layouts and so on, so here we have a lot of web stuff that has now been created for us in the views. In our app settings, you can see that is then a database. Now you can see there's a little database that has already been created for me because I'm going to be making use of the identity accounts. So let's just go and see. And what you can also see here is that it's already made some migration files for me. The application DB context is sitting here. You can see that is being created for me. Yeah, and I've got migration files. You can see these migration files that are sitting here are going to be used to actually create. You can see there's ASP.NET roles, and then we've got our claims and so on. So you've got all what we did in project 2, all those models have been created for us that we can use to actually go and create, there's your tables. You're going to create these tables. There's your user claims, and this is your logins. So all this stuff is already here for me because I selected that I want to use user accounts in this little application. The only thing that I would like to change in this little application is then if we look at the program.cs file, you can see, it's already gone and it's already now registered the DB context for me. It's in there, and you can see that it is using authentication and authorization for me, and some things have been done here. The one thing that we just have to change is we are using here the identity user, and what it says here, sign in require confirmed account. So normally, when you go and you register on a website for the first time, it sends an email to you and you have to confirm your account through the email, and it's going to do this here as well. So I want to change this into false. so that for the purposes of the demonstration, you don't have to do that. Right, so that's all I need to change. Nothing else has been changed, and I'm going to now execute this. Okay, so now I just created the web page for me, not the controllers, and you see that we don't have to worry about swagger and those things. So if I click on home or privacy, you can remember this was when I showed you the web page configuration. That is something that we saw there, and this is we are on our home page, and so we can now register. So in the background, the code has been set up in such a way that I can now register and use a little database in the background without any problems. So I can now, for example, create some account. Again, you must follow password conventions. And I can now register somebody. Okay, and so what's now happened is, if you remember when we looked at the code, the migration scripts were sitting there, but they weren't executed yet. But we can actually execute them from here. So you can see here that I still have to apply the migration scripts. I can apply them here, or in Visual Studio in the package manager. I can just basically go and do those commands. That is what we did before, .NET EF database update, but I can just actually do it here. And then I can then say it's applied it. I will refresh the page. And you can see it's actually now created my account here. And you can see that there is a profile created for me. So not only does is the migration applied, but my registration was also completed. You can see that is my email, my password. I can change here. I can put two-factor authentication. I can change any data that I want to change here. So you can see it's already done such a lot for me. So this is a basic web app that we now have available, and from here you can now actually go and take the code and add controllers. So this is essentially just to give you a little bit of an idea of what this web app consists out of, what the solution looks like, the different areas that we need to have a look at. And this is now where we are going to provide you with an application, and that is already been written with code. And you basically have to now go and add repository interfaces and classes inside your solution, modify the code that we give to you, test it, run it, and make sure that you then can implement the repository pattern to actually shield your data access from your application to ensure that it is a more loosely coupled application. Right, so that is then all from my side. I hope that this does help a bit, and good luck then with your project and its implementation.